Good morning, dear students. Today we will be discussing the equation of pair of straight lines passing through, not necessarily through the origin, to any other points. This is in continuation of whatever we have discussed in the last class. In the last class, if you recall, dear students, that we discussed about the equation of pair of straight lines passing through the origin and other relevant topics. So today also we will to do this thing. We'll start with the equation of the pair of straight lines passing not necessarily through the origin and the relevant topics. So the first and foremost thing what I would like to discuss here, dear students, is that the general equation of second degree. Okay. When we discussed about theory of equations, okay, and we discussed about this general equation of second degree. General equation of second degree is something like this in two variables x and y. Before me proceeding, could you please confirm that you are able to view the screen properly and
Yes, sir.
hear me very clearly?
Yes, sir.
Okay, great. So if you see, the general equation of second degree is represented by the following equation, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Now, this general equation of second degree, we will represent a pair of straight line. Okay, if we can express that expression, what you see in the left hand side of the equation, as a resolved into two linear factors. That means what? If we can, express this, the term ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. So what does it mean? It means is that ax square plus 2hxy plus by square plus 2gx plus 2fy plus c should be expressed as something like, I can say, a1x plus b1y plus c1 into a2x plus b2y plus c2, where all these a1, b1, c1, a2, b2, c2 are real numbers. Okay. Now, if we can express that expression, what you see in the left hand side, that is a general expression of second degree in x and y as a linear factor sub 2, then only we can say that yes, it is possible to that it is possible that equation, what you see, that ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of straight line. Okay, but under what condition? The condition we discussed, but how efficiently we can find whether it represents a straight line or not, and that is actually we need to find the value of the determinant. I'm going to show you, dear students, and if it is 0, then we can say yes, it is possible to express that general expression of second degree as a resolve as a two factors, or we can say the general expression is resolved into two factors. So what is this, dear students? Now this equation will represent a pair of straight lines if that left hand side of the above equation 7 can be resolved into two linear factors, which means the following condition needs to be hold true. That a, h, g, h, b, f, g, f, c is equal to 0. And if you find the value of this expression, you will get something like this: abc plus 2fgh minus af square minus bg square minus ch square. And dear students, and there is a technique how we can write the determinant. So the technique to write the determinant is something like this. You write, first you write the corner element abc. After that you go up f, then go up g, and then come left h. Here also same thing, f, g, h. Correct? So this is the way you need to find the value of the determinant. This you can construct the determinant first, because efficiently you can write the determinant, and after that finding the value of the determinant, so now based on the some conditions I'm going to discuss. Okay, we conclude the nature of the straight lines. What we can say is that moreover, based on the some conditions, we can say that what is the nature of the straight line. So that I'm going to discuss with you now. So what it says is that moreover, based on the following conditions, we conclude that the nature of the straight lines as real and distinct if h square minus ab is greater than 0. So h square minus ab is a very important parameter here. If h square minus ab is greater than 0, then we can say the straight lines are real and distinct. If h square minus ab is equal to 0, we say the straight lines are real and coincident. And if h square minus ab is less than 0, we say the straight lines are imaginary. But what we will discuss, dear students, as time goes by, we will be discussing when h square minus ab is either greater than 0 or equal to 0. That means we are going to, if we combine the first two cases, that means h square minus ab is greater than equal to 0. Okay, so this part we are going to discuss, that where h square minus ab is greater than equal to 0. So now if we see that that equation, that ax square plus 2hxy plus by square plus 2gx plus t5 plus c equal to 0, if you are finally able to represent as a two linear factors, then those two linear equations will represent the equation of the straight lines, correct? Okay, and here we can write like this, following are the equations of the line represented by that ax square plus 2hxy plus by square plus 2gx plus t5 plus c equal to 0. Let me show you this particular thing. Okay, now here is one interesting point. Okay, interesting point is that the equation, what you see is that ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represents a pair of straight line. Then the homogeneous equation of ax square, what will be the homogeneous equation? Homogeneous equation. So let me explain this with an representative example. Okay. Before proceeding further, let us solve a couple of problems. Then we'll proceed, and it will make more sense to us. Okay. For example, if we get this equation in this question, the first question, you please also open your notebook, dear students, and let us work together on this particular question. Suppose, as you see the question 1, these kind of questions are very relevant based on whatever we have discussed so far. The question here is that find the lines whose combined equation is 6x square plus 5xy minus 4y square plus 7x plus 13y minus 3 equal to 0. The combined equation, right? So how to find the the combined equation, and combined equation is given, but how to find the equation of the lines from here? So the way we need to proceed is that dear students, is we write the equation 6x square plus 5x square. So let me write it down, that equation first, that 6x square plus 5xy minus 4y square plus 7x plus 13y minus 3 is equal to 0. Now from here, what we are going to do is that we are going to rearrange this equation to express it as a quadratic equation in x. If we need to represent this as a quadratic equation in x, so how to write? It is 6x square plus, you need to write the x coefficient, so that is 5y plus 7 into x, correct, not dear students? Minus the constant term, what I'm going to write here is that 4y square minus 13y, 4y square minus 13y plus 3 equal to 0. Now, if you see this thing, this equation, what I just wrote, it is a quadratic equation in x. Now, as it is a quadratic equation in x, we can solve it. How can solve it? So, we can use x is equal to, if you recall this one, that how to solve, let me use a different color. If you recall this particular way of solving equation of quadratic equation, ax square plus bx plus c equal to 0. This implies what? X is equal to minus b plus minus square root of b square minus 4ac divided by 2a. Same thing we are going to apply here, dear students. So if we apply here, what we are going to get? X is equal to minus b. What is minus b? So that is minus of 5y plus 7. Minus of 5y plus 7. Then plus minus square root of 5y plus 7 whole square b square, correct? Minus 4 into a. 4 into a is 4 into 6 into c, that is 4y square minus 13y plus 3, correct? Divided by 2 into a, that is 2 into 6, that is 12, we can write. So now if you simplify further, dear students, so what we're going to get? So if we simplify further from here, we're going to get x is equal to minus of 5y plus 7 minus of 5y plus 7 plus minus square root of 121y square, 121 y square minus 242y plus 121 divided by 12. If any one of you get a different result, please do let me know. Now that becomes a little simplified in the next step. So 121y square minus 242y plus 121 is nothing but 11 into y minus 1 whole square, correct or not? So what I'm saying is that minus of 5y plus 7 plus minus square root of, you can take 11 into y minus 1 whole square divided by 12. So from here, what we are going to get, dear students? This implies x is equal to minus of 5y plus 7 plus minus 11 into y minus 1 by 12. Correct or not? Now we will take one plus value, one minus value. So if you take the plus value, then what we are going to get? We are going to get something like this. X is equal to, we are going to get 6y minus 18 by 12. 6y minus 18 divided by 12, or x is equal to, we are going to get minus 16y plus 4 by 12. And if we simplify further, so from here what we are going to get is that x is equal to y minus 3 by 2 and x is equal to minus 4y plus 1 by 3 minus 4y plus 1 by 3. Now just if we represent both this in the form of a general equation of a straight line, it looks like 2x minus y plus 3 equal to 0. This is one straight line. And the another straight line is that 3x plus 4y minus 1 equal to 0. 3x plus 4y minus 1 equal to 0. This is another straight line. I hope it is well understood, dear students, that how we can resolve into two factors from a general equation of second degree in x and y. Okay. So now let's proceed further. So the next one, what we can say is that the next question we can do a relevant question. The question is that find the value of lambda. Let me first place the question here, dear students. The question here is that find the value of lambda so that the general equation of second degree, as you see, 2x square plus 7xy plus 3y square plus 8x plus 14y plus lambda equal to 0 represents a pair of straight line. Now, dear students, if you recall, under what condition that general equation of second degree represents a pair of straight lines? That if we have the conditions true, that means if we resemble with this one, so what is our equation here? Our equation here is that 2x square plus 7xy plus 3y square plus 8x plus 14y plus lambda equal to 0. Now, if you just recall our our general equation of second degree in the general form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Correct, no? So if you resemble with this one, so what we are going to get, the value of a we are going to get is 2. Correct? So if we compare this thing, then what we are going to get, the value of a is equal to 2. Value of h is equal to 7 by 2. Correct, not, dear students? So let me write 7 properly. It is 7 by 2. Then b is equal to 3. G is equal to 4. F is equal to 7. And C is equal to lambda. So now, the given general equation of second degree will represent a pair of straight line if the value of the determinant is 0. That means A, B, C, F, G, H, F, G, H equal to 0. Correct? Now, if we expand this, this determinant, what does it mean? It means is that this implies the value of the expression has to be 0. What is the value of the expression? ABC. That implies ABC plus 2FGH, 2FGH minus AF square minus BG square. Okay, got it? Minus BG square minus CH square is equal to 0. Dear students, you can find from here also, as we discussed, this one. ABC plus 2FGH minus AF square minus BG square minus CH square equal to 0. This is the required condition, that the general equation of second degree is actually representing a pair of straight line. So now here all you need to apply the value of A, H, B, G, F and C as we obtained here, as you see here. So in context to our question, if we apply the value of ABC, A is equal to 2 into B is equal to 3 and C is equal to lambda. So 2 into 3 into lambda plus 2 into F, F is equal to 7, G is equal to 4, 2 into 7 into 4 into what we are going to get is that H is actually 7 by 2 minus A is equal to 2 into F is equal to 7 square minus B is equal to 3 into G square, that is 4 square, minus C is lambda, and H square, that is 7 by 2 whole square. That should be equal to 0. Now if we simplify further, dear students, okay, what we are going to get, you will get something like this: 6 into lambda plus 196 minus 98 minus 48 minus 49 lambda by 4 minus 49 lambda divided by 4 is equal to 0. And if you simplify further, dear students, so I'm not spending time in simplification because this is quite straightforward. So you will get the value of lambda equal to 8, and that is the required value of lambda. Okay, dear students, I hope it is clear. Now let's proceed further for the next topic. Okay, so the next one is that very interesting. If you see, there are two equations, okay, general equations of second degree. One, as you see, let me use a different color. Let me use this color. One is that, as we just learned today, that that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Now let us consider a homogeneous equation. What is a homogeneous equation? It becomes ax square plus 2hxy plus by square equal to 0. If you recall, dear students, that is a homogeneous equation. Now there is a relationship between these two. It says that this homogeneous equation, the second one, it will represent a pair of straight line. Na? So this will represent a pair of straight line. Now the pair of straight line represented by the general equation of second degree, what you see here, will be parallel to the pair of straight line represented by the corresponding homogeneous equation. Let me explain you by means of a pictorial diagram. So then things will be little clear. So suppose, let me first draw the coordinate axis here. So this is the origin. So now let's take this, that ax square plus 2hxy plus by square equal to 0 represent, two straight lines. Okay. So what are the two straight lines represented by this one? Suppose, this, equation represent two straight lines, something. They passing through the, origin. So y equal to m1x, and here it will be y equal to m2x. And let us draw this thing. Okay, so it's represented by, suppose, one green line and suppose one blue line. Okay, dear students, so this is y equal to m1x and this is y equal to m2x. And this is represented by the homogeneous equation ax square plus 2hxy plus by square equal to 0. Now, if this is the case, then the two straight lines, that is a pair of straight line represented by ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 will be parallel to this pair of straight line, but they are definitely not passing through the origin. So what it will be looks like, so this pair of straight lines will be something like this. This green line, just a minute, the green line is parallel to the green line and the blue line is actually parallel to the this blue line. So this is the joint representation of this one, that represented by ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. So that means what if we write? So this will be what y equal to we can write y equal to, sorry, so this equation will be y equal to m1x plus c1 and this equation will be y equal to m2x plus c2, because as the lines are corresponding lines are parallel, their slopes also should be equal. So this is what is the observation. Now if I write this thing from the study material, so it looks like something like this. So I hope you understood the concept. Now let me place the study material here, and after that I'll go through it, and so that you will understand it properly. So here it is mentioned that it is to be noted that if the general equation of second degree ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of straight line, then the homogeneous equation of second degree ax square plus 2hxy plus by square equal to 0 represents a pair of straight line passing through the origin and parallel to the first pair of straight lines. Okay. Now, dear students, as we understood this thing, one thing is obvious. Whatever the angle between the straight lines represented by ax square plus 2hxy plus by square equal to 0 should be the angle between the straight line represented by ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Right? So what I wanted to mean is that this angle, whatever you see, this angle, if it is theta, then this angle should also be theta. So from here what we can say, dear students, that both the angles, that is acute angle and obtuse angle, between the pair of straight lines represented by ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 is same as the angles, both acute and obtuse, between the pair of straight lines represented by ax square plus 2hxy plus by square equal to 0. Okay, so and how we can find it out? We can find it out, like this. Already we are aware of from the homogeneous equation what is the angle between the straight lines. Okay, so let me show it to you here. So that angle between them, if we consider phi is the acute angle between the pair of straight line represented by the homogeneous equation, then the value of phi is equal to tan inverse of 2 into square root of h square minus ab by a plus b. Now, dear students, so here just to make it resemblance with this thing, let me not consider theta. Let me consider here is as a phi. So this angle, if this angle is phi, so this angle is also phi. Now from the homogeneous, this whatever the relationship what you see now, that we have got it from the homogeneous equation, and same thing is valid, is going to be valid here. Now, as we understood this, strong relationship, between the, homogeneous equation and the general equation of second degree, in which the coefficient of x square, coefficient of xy, and coefficient of y square are exactly same. Let us solve a problem, related to this. Okay, and I'm going to, show you the, problem in few seconds. Okay. The question what I'm thinking to give is something like this. Just give me a minute. Let me. So this equation, I'm going to place it in front of you, dear students. I hope the question is visible to you. So we can define it as question number 3. So the question here is that find the lines whose combined equation is 6x square plus 5xy minus 4a square plus 7x plus 13y minus 3 equal to 0. And we have solved one problem today like this. But today, now, in this particular problem, I'm going to approach it, different techniques. Now, the equation what you see, dear students, here, that is 6x square plus 5xy minus 4y square plus 7x plus 13y minus 3 equal to 0. That is a general equation of second degree in x and y. So what will be the corresponding homogeneous equation? If you want to keep the coefficient of x square, coefficient of xy, and coefficient of y square intact, then the corresponding equation should be something like this: 6x square plus 5xy minus 4y square equal to 0. Now, whatever the equation represented by this means what? What I'm saying is that if this equation, represent two straight line obviously passing through origin, one is y equal to m1x and another one is that y equal to m2x, then the given state of given pair of straight line, so given general equation of second degree in x and y will represent something like this: y equal to m1x plus c1 and y equal to m2x plus c2. Obvious, because we just learned, and that the slopes of both the pairs of straight lines are equal. Corresponding straight lines of both the pair of straight lines are equal. So now let's concentrate on that 6x square plus 5xy minus 4y square is equal to 0. Let's concentrate on this. So, and if we factorize, what we are going to get, dear students, you are going to get 3x plus y, 3x plus y into 2x minus y. That is equal to 0. So from here, what we get, dear students? 3x plus y is equal to 0 and 2x minus. So what are the two equations what we're going to get? 3x plus y equal to 0 and 2x minus y equal to 0. So now what we will get is that, our required equation should be something like that. For this equation, whatever you see, 6x square plus 5xy, minus 4y square plus 7x plus 13y minus 3. So that means what? 6x square plus 5xy minus 4y square plus 7x plus 13y minus 3, that we can represent as 3x plus y plus some constant, suppose c1, or let's take the constant as capital A, into 2x minus y plus b. Correct? In this form we can write it down, dear students. Correct or not? Now, this is an identity. What you see, this is an identity. I hope you got it. Why? Because the slope of these two straight lines of the corresponding homogeneous equation will be the same as the slope of the straight lines of the equation represented by the given general equation of second degree. Correct? Now, this is an identity. What you see here, dear students, this is an identity. So the coefficient of x square in the left hand side should be equal to the coefficient of y square in the right hand side. Coefficient of xy in the left hand side should be equal to the coefficient of xy in the right hand side. Coefficient of y square in the left hand side should be equal to the coefficient of y square in the right hand side. Similarly, coefficient of x in the left hand side should be equal to the coefficient of x in the right hand side. Coefficient of y in the left hand side should be equal to the coefficient of y in the right hand side. And the constant term in the left hand side should be equal to the constant term in the right hand side. Now, if you compare this thing, and you will find, dear students, I'm not spending time on that. If you make this thing, you will find the value of a as -1, and you get the value of b is equal to 3. So then our equation represents, so the corresponding equation, what is that? This becomes 3x plus y minus 1 equal to 0. So this is one equation. This is one equation. And another equation is, 2x minus y plus 3 equal to 0. This is another equation. So these are the two equations represented by the given general equation of second degree in x and y. I hope you got it, dear students. Now, what I'm going to do is that I'm going to discuss the bisectors of the angles between the pair of straight lines. Okay, so a pair of straight lines represented by the general equation of second degree in x and y. So let me take you to the next page. So the point is that the general equation of this second degree, as you see, that let me represent these two straight lines. So one straight line I can represent in the green color, and another straight line I represent in the blue color. And these are the two straight lines actually representing jointly represented by the pair of straight line ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Now we are going to find the bisectors of the pair of straight lines represented by the equation, as I say. Now, if the straight line, this is only possible if they intersect each other. So here we are assuming, yes, they are intersecting. They are intersecting at the point, suppose, at the point alpha comma beta. So if you know their point of intersection, okay, finding the equation of the bisectors of the angle between this is very easy. Okay, so this will represent a pair of straight lines again. So what is that? So what will be their equation of the bisectors? Equation of the bisectors should be something like this. So let me, place it in front of you, dear students. Here it is. It is possible to find the bisectors of the pair of straight lines represented by the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 if the straight lines intersect each other. Let alpha comma beta be the coordinates of such point of intersection. Now, the equation of bisectors of the angles between the pair of straight lines represented by this equation as you see, x minus alpha whole square minus y minus beta whole square divided by a minus b is equal to x minus alpha into y minus beta divided by h. And if you notice, dear students, this is also a general equation of second degree in x and y. So it will represent two straight lines. So one is for the acute angle bisector and other one is for the obtuse angle bisector. Correct, dear students? Now, what we are going to do now is that, I'm just going to tell you some important results on pair of straight lines, and and I'm going to discuss all these things with you right now. So following are the some important results on the pair of straight lines. So let me first place the notes and then we'll discuss. Few points we already discussed, but I'm just making it as a summary. The first point, it says that the equation of the pair of straight lines passing through the origin and perpendicular to the pair of straight line represented by the equation ax square plus 2hxy plus by square equal to 0 is represented by the equation bx square minus 2hxy plus ay square equal to 0. If you see, dear students, you need to just replace the interchange the coefficient of x and y, and instead of xy you need to give minus xy. That's it. The second point is that the product of perpendiculars drawn from the point alpha comma beta to the pair of straight line represented by ax square plus 2hxy plus by square equal to 0 is mod of a alpha square plus 2h alpha beta plus b beta square divided by square root of a minus b whole square plus 4h square. And the third point is that the product of the perpendiculars drawn from the origin to the pair of straight lines represented by the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 is c by square root of a minus b whole square plus 4h square. Now, dear students, I would like to discuss the last point for today, and that will complete our discussion. That is the theorem on n straight lines. Okay, and here I'm going to show it to you. So, dear students, the theorem of n straight lines says that every homogeneous equation of degree n represents n straight line passing through the origin. Now let us consider a homogeneous equation of degree n in two variables x and y. So it will be something like this: n y power n plus a n minus y x into y power n minus 1, and in that way it will continue till a0 into x power n equal to 0 be the homogeneous equation of degree n. Then it must represent n straight lines passing through the origin. Now, as there are n straight lines passing through the origin, so we will have n number of slopes. So let m1, m2, m3 up to mn be the slopes of n such straight lines passing through the origin. Then we get the following two relationship. The first one is that m1 plus m2 plus m3 up to mn is equal to minus of coefficient of x into y power n minus 1, that is an minus 1, divided by coefficient of y power n, that is an. And the product of their slopes, that is m1 into m2 into up to mn, that is equal to minus 1 power n into a0 by an. So this is the theorem of the n straight lines. So we are done with today's topic, dear students. But before I conclude, I just want to give you um, two questions that you need to solve it, and do let me know before we start our next class tomorrow. The first question is something like this: that find the distance between the pair of straight lines. That is the first question, dear students. Okay, I'll appreciate if you submit it before our next class. And the second one is that let me copy paste from the study material. So the second question is that if the pair of straight lines ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 intersect on the y-axis, then prove that 2fgh is equal to bg square plus ch square. So dear students, with this I would like to conclude the class for today. Now you need to please appear a few DPPs from straight lines as available in the online test platform at konarclasses.com. In the next class, we will make some practice, and also we will start a next topic on two-dimensional coordinate geometry called circles. With this, I say thanks to you, and let's conclude our class.